In this video, we're going to look at parametric equations. We want to be able to recognize a parametric relationship, evaluate a point from a parametric equation, eliminate the parameter, and be able to graph an equation. Parametric relations are ones that are defined such that the ordered pair is given in terms of another variable t. So we usually have two equations, an x equation and a y equation, and it's written in terms of another variable t. We have an example here where we have x equals t plus 1 and y equals t squared plus 2t. So we're going to do three things: find points, sketch the graph, and find an algebraic relationship between x and y, which is sometimes referred to as eliminating the parameter. So the first thing we're going to do is find the points that are determined by this parametric relationship for t equals -3 to +3 given the integer values. So we're just plugging in values here, and I am just making a chart like you used to do, to just like a t-chart. So we just have 3 columns now. So when t equals -3, x is going to be -2 because we're going to do -3 plus 1. And then my y squared is going to be -3 squared, so 9, plus 2 times -3, so 9 minus 6, so that's going to give us 3. So just continuing to plug in these values, we're going to get, so these are the points determined by the relation. Now we're just going to sketch these so that we can get an idea of what my graph looks like. So I'm going to plot each of those points. So plotting the points that I can, the 415 is going to be off of my grid there. This asks me to sketch the graph of the relation for t goes from -10 to +10. So I kind of have all of the positive values that are going to fit onto my graph here, because we can see once we get to 4 the numbers are too big. You can see sort of the pattern that's forming. I'm going to just plot maybe another point or two. So I'm going to try maybe -4. So when t equals -4, then I'm going to get the point -3, and we'll get 16 minus 8, which will give us +8. So plotting the point -3, 8 gives me this point, and then it appears that all of the other points are going to be off. So we can see what we have here is a parabola. So we're just going to kind of connect the dots together to get this parabola. Part C, find the algebraic relationship between x and y, is essentially asking us to eliminate the parameter, which is to eliminate t. So we look at our two equations and we decide which one is going to be easier to solve for t. So obviously in this case, x looks like it's going to be the easier one to get t by itself. So I'm going to take that equation, I'm going to get t by itself, and I'm going to get t equals x minus 1. Then we take this equation and we plug it into the other equation. In this case, that's y. So y equals, and then instead of t, we're going to go x minus 1 quantity squared plus 2 times, and again, instead of t, the quantity x minus 1. Doing some algebra so that we can simplify here, we're going to get x minus 1 quantity squared is going to give us x squared minus 2x plus 1. And then in the second part, we're just going to distribute, so we got 2x minus 2. Then we can just combine our like terms, and we'll get y equals x squared. Our 2x's are going to cancel out, and then 1 and -2 is going to give us minus 1. So hopefully you recognize that this is a parabola that has been shifted down 1, so the vertex would be at the point 0, -1. All right, so taking a look at a second example, find the points determined by -10, -8, -6, -4, etc. until we get to 8. So it looks like we're looking at some even integers there and 0. We're going to sketch the graph of the relation, and we're going to find an algebraic relationship between x and y. So this time I want to use the graphing calculator to help us out here. Your calculator has a parametric mode, so we can put some of this into the calculator, which will help us get our answers. So the first thing we're going to do is go to our mode button, and we're going to come down to the line that says function, and you can see your next option over is parametric, or yours may just say PARA for parametric. So choose your parametric mode. What you'll notice then when you press your y equals button is that it looks a little bit different. Now you have an x sub 1t and a y sub 1t and x sub 2t, etc. So remember, this allows us to put the x and the y equation in. So given our example here, we have x is the absolute value of t minus 5 and y is just t minus 2. So I'm going to put this in. So I'm going to go to my math option to get my absolute value. And then if I look at my X button, you can see that it actually has X comma T comma theta comma N. And so when I'm in parametric mode, if I press that button, I'm going to get the T instead of the X that we're used to. So that was T minus 5. And then use your arrow key to go down. You have to put the Y equation in, and then we're going to go T minus 2. If you notice there, the black highlighting around the equal sign did not show up until we started to enter in the second equation, because you cannot graph unless you have both the X and the Y equation. So a couple of things I can do here now. I can use my table to help us get these points. So I'm going to go to my table settings, and I'm going to start my table at -10, and I want to increment by 2. And then I'm just going to leave my independent and my dependent both on auto. So then if I go to my table, I should see the points that I was looking to get. So if we grab those, so that's essentially my answer to A. So using the calculator, I can kind of get those points rather quickly. We also want to sketch the graph. So once we have those in our Y equals, we can get the graph. So just pressing my graph button, I can see that I have a sort of an absolute value graph here that's opening towards the right. Specifically, this graph said graph this for -10 to 8. So once you do that, I want you to press your window button. So we want to graph this equation from -10 to 8 for T. So we're going to press the window button, and we're just going to make sure that our Tmin and our Tmax match up for that. So ours goes -10 to 10, which is a larger range than what was asked for. We could change it so that it matches up exactly. Put that there, and then we can take a look at our graph. So you notice that it's actually a little bit shorter than it was before. So I'm just going to grab that from the calculator. All right, remember that part C asked us to find that algebraic relationship, so this cannot happen in the calculator. So again, we're going to look at our X equation and our Y equation, which one is easier for us to determine to get X or to get T by itself. And in this case, it happens to be the Y equation. So here we're going to go T is Y plus 2. Then again, take that T value and we're going to plug it into the other equation. So now we're going to have X is the absolute value. Instead of T, we're going to write the Y plus 2. And then we still have the -5 inside those absolute values. In this case, we don't have a whole lot of simplifying that we can do, but we can combine the 2 and the -5. So we get Y equals the absolute value of Y minus 3. And then that's my answer to eliminating the parameter. At the end here, I just gave you some directions, reminders on your calculator of how to graph in your calculator. So you need to change your mode to parametric, go to your Y equals. You can use that X button, which will get you your T. And then always pay attention to your window, particularly your Tmin and your Tmax, because the directions will typically tell you what T values you want to graph over. Additionally, we want to look at graphing those parametric equations in Desmos, which really is essentially just typing in the point. So when we have this graph here that we had was absolute value of T minus 5, and then Y was T minus 2. So if we just go to Desmos, what you want to do is just type in the coordinate pair, so do parenthesis, and then we want absolute value, T minus 5, and then we just had T minus 2. We want to put in the range of values that we want to graph over, so -10 to 8, and then we can get our graph there.